Alright, find the slope function for each of the following. So y equals 2 times e to the x plus 3e to the negative 3x. So the first one is easy. Derivative of e to the x is e to the x. So we have y prime is 2 times e to the x. Nothing changes there for the derivative. And then for the second function we have 3e to the negative 3x, which is going to be 3e to the negative 3x times the derivative of the function in the exponent, which is negative 3. Okay? And then simplifying then, this is going to give us 2e to the x minus 9e to the negative 3x. There's our slope function. In B, I have a product of two functions, now one of them involving e to the x. Okay, so I need to use the product rule. So remember how to use the product rule. We let u be one of our functions, which is x squared, and then we take the derivative of u with respect to x, and this is 2x. And then we let v be equal to the other function, e to the negative x, and then we find the derivative there, dv dx, is negative e to the negative x. Now we apply the product rule, right? So y prime is u times the derivative of v, so we have x squared times negative e to the negative x plus v times the derivative of u, so e to the negative x times 2x. And then we can just simplify like this. We have negative x squared e to the negative x plus 2x e to the negative x. We could actually factorize if you like. We could factorize e to the negative x. We take out e to the negative x and it leaves us with negative x squared plus 2x. In fact, we could have actually factored out another x as well. Maybe we should just do that just so that people don't understand why we would only factor that. So if I factor out an x e to the negative x, then we can write negative x plus 2. There we go. And in the third one, we have two functions, the quotient of two functions, which means we need to use the quotient rule. So we'll do exactly the same thing. So we let u be the top function, e to the 2x, and then take the derivative du dx. We take the derivative du dx. This is going to give us 2e to the 2x. Right? E to the 2x times the derivative of the function in the exponent. All right? And we let v be equal to the denominator. So v is equal to x. So then, therefore, we have dv dx is equal to 1. Now, to apply the quotient rule, we look to our formula booklet, and we can see that we start with the denominator v, so it's x, times the derivative of u, 2e to the 2x, minus u, which is e to the 2x, times the derivative of v, which is 1, all divided by the denominator squared, x squared. And then we can simplify this a little bit here. We have 2x e to the 2x minus e to the 2x, all divided by x squared.